Okay, fine. We're doing the RX 580. So, hello everyone, welcome back to another video, and, well, we're doing the modded RX 580. Finally. I've waited a long time for this, and I have received a lot of comments asking for this video, actually. It's not typical that I get comments asking for stuff, especially the same thing, so people really want to see this video. And I wanted to make this video, but for reasons I didn't. Yeah, so this RX 580 originally got modded a long time ago with the intention that I bench it at the bench meet in Stuttgart. That didn't end up happening because we ran out of time and we would rather focus on the Fermi 1.0 cards because we focused on the scores where we either didn't have any scores or had the worst scores. And as far as RX 580s went, we either already had scores or we had other people who could also bench other cards, whereas the Fermi 1.0 scores, we just didn't have any. So we focused on getting those, and we ran out of time. So this thing did not get benched, and I took it back home, and since then it's sat around. I thought about benching it a couple of times, but I never did. Mostly because uni stuff was happening and I just didn't have time. And when I had time, I would rather do something else than to deal with this. For those who don't know, I have a curse. And that curse manifests in every single time I try to use a Radeon graphics card, something breaks. You saw it in the last video about this thing when it just stopped working and then started working again for no reason. I'm just gonna say this is the third time I'm recording this video. And can you guess why that is? The card works, it's not that bad, but let's just take a look at the back. So, right here, some things have changed since the last time you've seen the card, and you will notice some flux residue on the card over here. So, last time you saw this card, there was a I2C connector right here on this header named J4001. This, in that video I said, is the I2C connector. And that is true. It is an I2C connector. Just not for the VRM controller. So there's actually 3 headers on this card, and most RX 580s. For example, here is an RX 580 reference PCB, and it also has this, and this header, the same ones as this Gigabyte card. And I had to go and confirm this. I went and found a schematic for this specific card. I can't tell you where I found it or how I found it because I legally can't tell you, so please don't ask. But I found a schematic, and I was able to confirm what each of these headers are, or at least what kind of thing they do. So, yeah, this down here, yes, it is an I2C connector, but the only places it connects to are the I2C pins on the PCIe slot, which I didn't know it had, but apparently the PCIe slot has I2C pins, and I2C pins on the GPU. Those are the only places this connector connects to. So, yeah, this is I2C, but you can't control your VRM controller through this. Then over here, we have a connector named J4003. And this is very misleading, because if you look at a newer AMD card, literally anything that came after this, so Vega and anything that came after it, J4003 is the I2C connector for the VRM controller, at least according to Boltzoid and the video he just released today. And I trust him on this, because Polaris is the newest AMD generation I've ever used, so I have no way to know, but I trust him with this, and he has worked with those newer generations, so when he says J4003 is I2C for the VRM, then it is I2C for the VRM, but on this, it is not. So J4003 also connects 2 GPU pins. I don't exactly know what pins those are, because the schematic didn't really give me any info to work off. They are either GPIO pins or like some debug pins, I'm not sure. But this also does not connect to any VRM controller. Which is why the wires are now soldered here. So this is another connector. It has a physically different footprint, and this is connector J4005. You can maybe see it like on this. It's really small, but you can. Yeah, it's probably too small. But like this is connector shit. This is connector J4005, and this actually has I2C that is connected to the IR3567B that controls vCore and I think memory? I'm not sure. It's a dual output VRM controller. So like either also, yeah, like it should be memory because that looks like a small one-phase VRM controller for the VDDCI, which is like right here. So yeah. So this is the connector. So both of these are wrong. So the one that I said is wrong, and the one that every other newer AMD card uses is also wrong, which... So this connector up here, pins 7 and 8 on it, which is where the blue and purple wire are SDA and SCL, and the two pins on the left, so the green, where the green one is and the one below it, those are both ground. And this, at least according to the schematic, connects to the I2C pins on the IR3567B. The problem is, I connected my EVC to this, and it doesn't show up. There are 0 devices present, even when I swap the data pins around. Just nothing. So, I don't know. I have no idea. Like, the schematic doesn't show that there's like a bridge or a resistor that could be missing in between. Like maybe there is, but the schematic didn't show it because like it's like the header is on one side in the schematic and then the VRM controller is on another side, and it just says that like, hey, this is the pin has the same name. Because in the schematic, these are named as like regulator SDL and regulator SCL, which only shows up on this header and on the IR3567B. So like this should be the same connection. I don't know if there's a resistor somewhere along the way that's maybe like just not populated on a card, and you might have to put it on. Like I can't see anything that looks like that. So I have no idea. Like, why can't this thing see it? Why is it not there? So, the only thing I can think of, and this doesn't really make sense to me, is that the I2C bus might just be locked. So, I remember there was a thing like that you can lock the I2C bus, and then it just, like, it's just deactivated, it stops working. And that maybe could mean that you can't see any addresses anymore. I don't know if it just makes it that nothing shows up anymore, or if it makes it that nothing responds anymore. I don't know, but maybe that could make things not show up anymore. The question is, why would you lock the SoC bus, the I2C bus? Because this is an AMD card. Like the card that I know locks the thing. Those are like NVIDIA 20 series cards. So like I remember Der Bauer had like a video with like an RTX 2080, I think, where they shorted out the I2C bus while the card was booting up, because otherwise it would lock the I2C bus, and you know they wanted to use the EVC with it. But that's an NVIDIA card. NVIDIA cards are analog. They use PWM-VID to communicate with the VRM. This doesn't. This is digital. This should rely on the I2C bus to like talk to its VRM. So this shouldn't lock the I2C bus, because then it would just not be able to control itself anymore. So this doesn't make sense to me. So I don't think the I2C bus is locked, and that's the only explanation I could think of why this thing doesn't show up in the EVC. Like, so I'm just confused right now. Like, and I'm just kind of, well, what do we do now? Okay, so the plan for today is I'm just gonna overclock this Like, I'm gonna really max it out. It will hopefully survive, more on that in a bit. And if it survives, I'm gonna do a test run with my phase change to just see how this thing behaves cold. Maybe I have to do a PEX rail mod to like make it work at cold temperatures. And if everything works, if it survives, I'm taking it to the next bench meet, which is about 2 months out from where I record this. And then we will hopefully properly bench it on LN2. That's the plan. So today, I'm gonna be just maxing it out, like core, memory. I don't think I'm gonna like do a BIOS mod for like memory timings, because that's a really long and drawn out process. I should probably do that if we want to like do the bench meet, because then it's an advantage that we're not taking if I don't. So I guess that's just a thing I can work on the side to just like see what kind of memory timings this takes. But yeah, so today we're just gonna bench the card. We're probably not going to use I2C because like it just doesn't show up. So stock voltage for now, which like Der Bauer said, his RX 480 and like 580s are very similar. His RX 480 is scaled all the way to 1.35 volts, and without EVC I can only get this to 1.225 volts. So there's some headroom that we're losing out on. So I'm not super sure. We could always do the analog volt mod, but I really don't want to, because the VRM controller, like it's on the front of the card. It's right there. And I don't like to solder anything around there, because like this is where the block is, and when I like remove the block, we put a LN2 port on, like this is gonna be in the way. And this just sounds like a nightmare to deal with. So I don't want to solder anything in this area. So I'd really like to get the AVC working. Like I don't really know how to make it working, but I don't know. Maybe someone else had this problem before and has found a solution. But yeah, so we're just gonna be overclocking this normally today. It's not gonna be super exciting, but I am gonna look that we get it like as well dialed in as it goes. I'm gonna do some software tweaks, and we're hopefully gonna get like a pretty decent like Firestrike score or something. And it will hopefully not explode. So the one thing about this card, this has a 6-phase, and it has a 6-phase with more MOSFETs than like this reference card has. But the MOSFETs on this are not that great. So I've seen this PCB blow up several times, so this VRM is not great even at stock. And now I've removed the backplate, which had a heatsink, and like the backplate is metal and it had a thermal pad for the VRM. I've removed that because the capacitors are on the back. I thermal taped these huge heatsinks on, which do seem to work pretty well, and I have like a big Noctua fan just like blowing air at this thing. The VRM gets very hot still, like very hot. You cannot touch the back of the card. Like it hurts so much, it's so hot, you cannot touch the back of the card when it's running benchmarks. And that's like a 30-second benchmark run. This is not like a game, like a sustained load. I'm pretty sure the VRM would just up and die if I do that. So I'm a little bit concerned that maybe this VRM is going to blow up. Like outshot is only 60-ish degrees, and MOSFETs can typically do like 100 at least, but the current handling capability goes down the higher the temperature goes. So there's like a thermal runaway scenario you can have where like the MOSFET gets so hot it can't handle current anymore, and like more heat also increases the resistance. So like like more heat generates even more heat, and then the current handling capability is gonna drop down and down and down until the thing explodes. So that's not very great. So I hope this thing doesn't explode, because this will be very, very hard to repair if it does. Because there is actually a fuse on the PCIe slot right here, but the 8-pin is not fused. And the VRM is on the left side, you know, where all the display outputs are, and like some other stuff that the card needs. If this MOSFET blows up, and I drill out the short, there's a good chance we just, like, the card just stops working. And then if I drill up the short, well, we lose at least one phase, which is a problem because you also can't e-power these. Like, you'd need one of ASIC's, like, new prototype e-powers to e-power this, because you need to reuse the stock PWM controller, because, again, the card talks to it over I2C, and if it doesn't talk, then the driver doesn't know what to do with that, and it crashes. So, annoying. Like, I mean, I got the card for very cheap. I think I paid like 30 euros for it. And it's a 4 gig. And it has LPDA. So, like, this, it's not like it's gonna be a huge loss if it dies. It's just that I will only have this card left. And this is a reference card that has its own set of issues. And then I'd have 5 Polaris cards, of which only 1 is working. So, yeah. So, I hope this doesn't die. And I've rambled on for, Jesus, that's a long time. So let's just set this up. I'm gonna do my testing. I'm gonna do my dialing in. I'm gonna try to get the best score that this thing can do. And maybe if there's time left, I can see if I can do something with I2C, like somehow make it show up. And that would be neat. And then maybe I put 1.35 volts into the thing, and then maybe the thing blows up. So we'll see. Anyway, let's set this thing up. Before we continue, I'd like to thank my sponsor, PCBWay. If you are working on a project of your own that requires parts that would be hard to make yourself, or just generally parts at a much higher quality standard, you can go to PCBWay's website and order anything from PCB prototypes, assemblies, CNC parts, 3D printed parts, as well as stencils or even flexible circuit boards. The ordering process is simple. You just upload your files, tell them some stuff that you need, and you'll quickly receive a quote, which once accepted, will mean that your part can get shipped out within as fast as 24 hours. And if you have any questions or require further help, they even have a live chat service that stands ready for you. So if you need some custom-made project parts, don't delay, go to PCBWay today. Alright, welcome to the setup. As you can see, we are using the Insta360 Go 3S instead of my capture card because the Radeon curse continues. My capture card doesn't like the graphics card. I don't know why. It shows an image for 5 seconds and then it just goes black. And I haven't found a single way to fix it, so there you go, fisheye lens. But I also have good news. So, I have recorded this entire thing about how the I2C bus doesn't work and the EVC can't see anything. And then I try it again, just to see, like, I don't know, maybe I plugged something in wrong, even though I made sure I didn't. It works now. Like this card before, just like it was dead until it wasn't. And the IR3567B shows up now. I don't know. I don't know why it's doing that. It works. And I'm not complaining, but like this graphics card doesn't make sense to me. So yeah, even like the custom applied voltage even shows up in GPU-Z, and yeah, we can even affect the power draw. So like the I gain, if we change that, this goes up or down. Though the current numbers it's reporting in the EVC software are like completely wrong. The input current is way too high, and the output current is way too low. So, like, I wouldn't trust those. And also, let's check the VRM temperature. So, it's not hot, but it's, like, getting uncomfortable to touch. And this is just from the render test. Like, this is with 100 watts of draw. We can, like, double this. Actually, what's the power limit on this? Does this have a power limit? Oh, 160 watt. So, yeah. And we're doing 90 right now. So, VRM is gonna get toasty. Did I just crash the card? Oh. What just happened? The driver crashed. The driver just crashed. Because I closed the render test, and now we have MS Afterburner graphs and GPUs. Oh my... I hate Radeon graphics cards. Let's just reboot and pretend that didn't happen. Great, it's not booting anymore. That's cool. Love it when it does that. It's been like 45 minutes and I haven't run a single benchmark yet. But no, the AMD drivers are fine. They work just fine. It's not that bad. It works just fine. Okay, the image is back. Okay, I can stop complaining now. Okay. How about, first thing, we set everything to stock. I have, when I installed the driver, already done the, wait, what? Where's the driver? The hell? It says I'm running it. Where's the... Why is it not in the right-click menu? It was there last time I checked. Okay. Anyway, AMD drivers. Let's just, yeah. So under graphics, I already changed the things. So I set all of these adjustable ones to the lowest value they go. I turned off tessellation, and I set texture filtering to performance. So those are the tweaks already, and I don't remember if I did these. I haven't done this yet. And let's check if I did the power settings. Yes, this one's on ultimate performance already, so I did those. Actually, let's check if game mode and stuff is properly applied. So let's use this nice feature of Ghost Spectre Windows and check. So we want 39, 3. And I want to enable game mode. Yep, now we have ultimate performance 3 times, but that means game mode is on now. And okay, this doesn't have any option for that. Alright. Then 3D Mark. Let's just get a baseline. Like, yeah. It should be, software-wise, like, optimized as far as it goes. This is not going to be 3D Mark Hall of Fame legal because tessellation is off, but in Firestrike at least, this is HWBot legal. I think it is not in newer versions. Also, I'm not sure if I need to update to this. This is... I'm on 17, the new version is 31. But yeah, so let's just run Firestrike at stock. I just want to know the baseline. That's what we're doing. Why did my screen just turn off? What? Okay, it's back. Why just do it? AMD. I want to have Reaver Tuner on. This might not be great for performance. It shouldn't really affect it that much, but it's probably not great that it's doing processing. Actually, I think I'm gonna leave this on just to like look at the temperature and the clock speed in real time. And also the voltage. I'm gonna check the EVC real quick if this is like representative of the actual voltage. It is. Okay. Like, kinda at least. It's not at 1 volt anymore. The screen is like 3 meters away from the test bench, so I can't like... I need some time. And if the voltage changes in that time, then... But yeah, I'm gonna keep Reaver Tuner on. It says it's an RTX 2080, ignore that. I'm gonna leave that on so I can look in real time, and then for the final score run I'm gonna disable it to get that extra boost, because it shouldn't be that much. Okay, that is a pretty decent score already, like 16.6k. That is... yeah, like, yeah, that's pretty good for like one of these cards. At stock, I will also say, like, this is just stock. This should be way better, and admittedly, yeah, it's invalid score because tessellation is off and everything. Wait, is that... shouldn't this be like way higher? Yeah, this should be... oh, is it? Shouldn't this be like 35,000 or something? Maybe I just remember it wrong, but I think this is like very low. Alright, there is our baseline. 16,500, that is very good. Very, very good. Like, that is, for stock, a very good result. Yeah, because like some RX 580s struggle to get here, like with an overclock. I realize the stock clock for this card is rather high at 1365, but it can go higher, and we haven't done any memory overclocking yet, so this looks pretty good. Maybe we can get to like 18k, like that's starting to get into like GTX 1070 territory. So yeah, let's see if we can do that. So I'm just gonna load my generic profile here. That's just maxed out power limit, maxed out voltage, 1400 core and 1900 memory, which is not super high, but like better than what we just ran it. The card should do it. So let's run that. Alright, that is not as much as I had hoped. Honestly, I thought it would be a bit more than 250-ish points. So maybe 18k not happening without a memory timing mod. Like, it's probably not happening today. But 17k in the realm of possibilities. Very possible. Because, like, I don't know where it ends, but we're already halfway there from where we started. So if we just keep going, there's a decent chance we can make it. And one thing I'm also going to do is I'm going to put the camera up a little bit higher because the glare from the lamp makes everything unreadable, so let me fix that real quick. Alright, it's even more fish-eye now, but at least you should be able to read all the numbers like up here from RivaTuner when the card is running, so yeah, now I just need to deal with the camera being in front of my face instead of a screen. So, let's keep pushing it, I guess. Let's try like... what? 2,000. There we go. And 1450. Why not? Let's see if it does it. Oh, let's look at that. That was a pretty big increase. I mean, we jumped 50 megahertz, which is more than last time, so... yeah, core clock seems to be a lot more important for score than memory. At least in the graphics score, like the combined score, from what I remember, is usually memory clock heavy. Yeah, that's great. So I don't think we're making it all the way to 18,000, but yeah, it's like... I don't know how more the core has in it, but like we have EVC control now, and Bauer said his cards get up to 1.35. We're just slightly over 1.2, so still headroom to go. Okay, so memory clock seems to just not matter at all. Like, the score did not change, despite me bumping it up to 2200. I mean, maybe it just, like, if it just runs maxed out slider, I guess that's fine. I'll just leave it at that, and then only push core. God damn, that's a lot. Okay. 1500 core passes. Only problem is we're getting really close to the 220 watt limit, which I can bypass, but the VRM is also getting very hot. Like, very hot. I'm not sure if I want to bypass the power limit, because that might be where this card dies. Okay, let's go in slightly smaller steps now, because this is like sorta, like, a good card will do like 1600, but I don't know if this is a good card. Okay. You know, maybe 18k is happening. If this is a really good card, if this does like 1600 on the core, maybe 18k is happening. Okay, oh, it's getting very close. If this does 1600, we're getting 18k. Like, yeah. We passed 1550. Like, this is officially in good card territory now. Let's hope it gets into very good card territory. Ah. Okay. That looks like a fat no. Damn, it's really crashed. It's not coming back. Yeah, it's completely crashed. Like, the keyboard doesn't respond anymore. Oh. Is it rebooting? No? Ah, it fixed itself. Okay. 1575 is not happening. Not at this voltage. So, actually, let's... We have like another 20 watts or so of headroom. So, I'm gonna apply more V-Core and see if that does it. Oh, I saw artifacting and it immediately crashes again. Yeah, like it, the voltage applied, we're drawing more power now, but like this immediately crashed again. So that does not really, yeah, that does not really show us much. So we can probably get the card to clock higher. The temperatures are very good. We haven't even crossed 40 degrees. And we can probably get the card to clock higher. But it probably needs a lot more voltage, like 1.3 volts or more. And with how hot this VRM is getting, I'm just not comfortable applying that with ambient cooling. When I have the phase change connected, or especially when I have an LN2 port on it, all the cold will like soak into the PCB, and that will also cool the VRM down. And then there's also the part where like a cooler running GPU draws less current. So there I would be comfortable applying more voltage. Like at the bench meet we had this GTX 465 that was a reference PCB, and it had no VRM cooling whatsoever, and we run it at like also 1.3ish volts, and it was completely fine. Like the VRM didn't even get like warm. So if you have the card under LN2, it just draws less power, and because there is liquid nitrogen cooling the card, you know, some of that also cools the VRM. So I would be fine doing that there. I'm not fine doing it right now. Like, that VRM was getting very hot. Like, the little temperature sensor in the EVC software showed like close to 80 degrees. And the thing is, that temperature sensor is going to be like a little thermistor, like resistor, somewhere between the MOSFETs. So that means if that thing is seeing 80 degrees, that means the PCB around the MOSFETs is at 80 degrees, which means the MOSFETs themselves could be at like 100 or 110 or even more. And that's like that's the point where if you go higher, they blow up. So I really don't want to push the voltage up anymore. And like the little bit that we can push without crossing the power limit doesn't seem to do anything. I think we just need a lot more voltage. So there's one last thing that I can try. There is extend official overclocking limits. Maybe this will let us apply more memory clock and get some more performance that way. But I'm a little bit disappointed that the core just stops here, and then like even a couple more millivolts just don't really change that. Like it crashed exactly at the same point. It didn't even last a little bit longer. So yeah, if I have time for the phase, and if I feel the VRM is like cooler on the phase, I'll do that. I'll apply more voltage there, but like today I'm just not comfortable. I don't want to kill this card yet. So, oh wait, it's, wow, it lets us do 25 megahertz more. Okay, buddy. Let's do like 1560. Well, let's see, maybe that works. Like, if it's a very, very hard wall of where it stops working, maybe we can do like 1560. And maybe that gets us, well, actually, we were like fairly close to 18k. Like, if we get lucky and we get a run that performs very well, maybe. I'm not getting my hopes up, but maybe. Oh, so close. So close. Oh. Oh, come on. Like, but it's really funny how 1575 immediately dies and this passes without artifacting at all, even though it's just 15 megahertz. Like, I don't know, 1565? Maybe that works? Maybe we can get another 90 points out of it? It would be like really cool if we get 18k here. That would just be like a really nice like thing to cap off the video with. It's kind of crazy how we're drawing like 200 watts and it's below 40 degrees. Like, there's a point where if you make your water cooling loop bigger, it just doesn't help anymore because you're reaching the limits of what the block is capable of like transferring into the water. And like, this is not an expensive block. This is literally a cheap AliExpress block. And like, my 2080 Ti and my daily, it draws a similar amount of power, and it's at like 43, 45 degrees. And it has a bigger die, which makes transfer easier. I think the reason this performs so well is this metal plate that's on top of it. That's actually from like a big custom air cooler. It's like meant to be used as a backplate. But it's bent so that the middle part is slightly lower, and I've been using it as a retention bracket. And it's been giving me like very good mounts, like really, really good mounts. Like you can see the thermal paste just perfectly spreads. There's just a very, very thin layer. So that's cool. I just hope I had something like that for my phase change, because mounting it is the biggest issue of getting it to perform well. Okay, what are 5 megahertz worth? Okay, 10 points about? This is gonna be very tight. Like, this is probably not happening. maybe if I just keep rerunning it over and over and over, we get like one run that performs really well, but I think 18K is just out of reach for this setup. I think we need more voltage, and for that we need lower VRM temperatures. Like, that's the limit. If this had a better VRM, I'd just shove voltage into it, but like, not comfortable with this. Maybe I should, maybe I can replace the MOSFETs with like better ones. I don't know with what though, but maybe I could try that. Oh, come on! 7 points? Really? Okay, at this point this is rerun variance. Unless this is the 1 in 100 runs that performs really well. If we just keep rerunning this, it should just work. Like, we should get our 18K. Because like 1575, that's where it ends, that's where it crashes. Can I do 1574, just 1 megahertz lower? Can I do that? Like, I've seen this on my 5800X 3D. It will not do 1900 FCLK, but it will do 1880. Like, what was it? 1897 or something? Like, very close, and that's like completely stable. Oh, I think I saw artifacting though. And it died. Made it a lot further than 1575 though, like maybe 1573? Maybe that's it? Nah, this is getting worse. I just want 18K. And we have completely lost this playout now. Yeah, I think at this point I just need to rerun and hope I get a run that's just a little bit better performing. Actually, let's turn off Reaver Tuner and see if that fixes it. Let's also turn off Afterburner. Maybe, just maybe, this does it. Oh my god, it happened! Yes! Just rerunning it works! Alright, there we go. 18,000 GPU score. This is, like, for an RX 580, this is very fast. Very, very fast. Admittedly, yes, we're using the tessellation tweak, which adds a decent bit to the score, but it is hardware bought legal, so I don't care. 18,000 score, this is, like, yeah, this is nearing GTX 1070 territory. It's nearing slow GTX 1070 territory, like fast GTX 1070s are like 22,000. But if you're looking at like a reference card with like a blower heatsink and a crappy power limit and it's not overclocked, it's gonna be somewhere in the 18,000 range. Probably not exactly 18,000, probably like a little bit higher, but like this is touching that range. Like the next level, because the RX 580 is like usually compared to a GTX 1060. It's a bit faster than a 1060, but a lot slower than a 1070, and now we're like just a bit slower than a 1070. And that's really cool. So yeah, that's how far we got today. So let's bring it up again. Highest GPU core clock, 1570, which is, honestly, this is really good. Like, this card has a good core, which is the reverse of what I usually get. Usually I have cards with good memory and then a crap core. But this actually has a good core, and the memory isn't bad either. So it just maxes out the slider. Admittedly, well, it doesn't show up at all, but like I did the minimal installation of the driver so that I would have the settings to like turn tessellation off and stuff, but I haven't installed the extra features like the in-driver overclocking stuff, because that tends to interfere with MSI Afterburner and other things, and it tends to screw up your scores. So I didn't install that. It would have let us choose a tighter timing strap. That maybe could add a bit more performance. I just haven't done this here because like I don't like dealing with the in-driver overclocking menu. It's just really buggy. So yeah, like the memory just maxes out the slider. I'm kind of annoyed that the extend limits thing just adds 15 megahertz. Like, and it's a bit annoying. But like this is really high. Like this is on Elpida memory, which is usually not good. Like I've actually had pretty good experiences with Elpida. I have another Elpida, an R9 that's also really good. Like in my experience, Elpida on AMD cards is on par with Hynix chips, which are typically the better ones. Like, I haven't had a Samsung card yet, but of the Hynix chips, the Elpida ones are typically on par with the better ones. So there's like Hynix MFR and AFR on like HD7970s and Tahitis and stuff. And the AFR is the better one, and that's what the Elpida is closer to in performance and clocks and stuff. So yeah, like it's a pretty good card actually. I didn't expect this. I thought this would kind of suck, but like, yeah, it doesn't do 1600 on the core, but honestly, 1600 on the core, this would have been like a golden card, like actually golden card. 1570 is not bad. Like that is pretty good. I don't know how much all the mods I did do for this. I don't remember if I even tested the card beforehand. I think I ran it a bit, but I don't really remember what it did before. It certainly didn't do this. I'm pretty sure. I'm pretty sure it did not do way over 1500. And I also think it didn't do over like 2100, 2200. I could be remembering this wrong. It could also just be the better cooling. But like, the card's really good now. Like, yeah, this is honestly really good. And that means this card is absolutely worth to keep benching. So I'm gonna do my phase. Next thing. Right now it's pretty late. The 1 PM on the desktop is not correct. This is very wrong. Yeah, like I'll put my phase on this. I'll see how that performs. I want to see how this behaves cold. I will probably add a PEX rail mod because at least for LN2 this is probably just required. And I'll see what it does. Like, yeah, this is absolutely worth continuing. I'm just really hoping that the VRM is not going to explode. I'm really sketched out by it. I actually maybe want to look into the option of replacing the MOSFETs, at least the high-side MOSFETs, because those are typically the ones that explode. I could maybe order some high-spec high-side MOSFETs, because I don't really have any cards that I can steal them from. Like, I can maybe check if I can find like a donor card that has pretty strong high-side MOSFETs that like fit the footprint on these. Otherwise, I might have to order some. But yeah, like, I'll continue with this. This is really promising. So now I'm kinda mad at myself that I waited so long to bench this thing. Because it's really good. Like, yeah, this is, like, compared to Buildzoid's RX 480s, I think this beats them. I think this straight up beats them. I don't know if I beat his score, because he did LN2, and they probably outmatched this card in that state. But I don't think he got, like, a 1570 core card at Ambient. I'm not too sure, but I think he didn't get that. So this card is like pretty good. Maybe I should rewatch all the old actually hardcore overclocking RX 480 videos. He had like 3 of them, a reference, a GTR, and then like another one that was like supposed to be a golden sample, but then it was like really bad. Yeah. Anyway, I'm dragging this video out more than it needs to be. So here's finally the RX 580. It's finally overclocked and it's doing really well. And this is not the last time the card will run. I will not tear down the test bench. I will keep it like this, and I will just set up the phase change to run the next time I have time for this. And then I want to do a full investigation of just how this thing does cold, like how's the scaling, how's the behavior. And then once I figure out how this thing ticks, I'll take it to the next bench meet, and then we're putting liquid nitrogen on it, and then it hopefully still doesn't die. And yeah, I wonder if RX 480s with 4 GB of VRAM have a separate category on HWBot, because that if they do, this would be a very, very easy gold, because I don't think anyone bothers benching the 4 gig cards. So yeah, but let's see. For this video though, thank you all for watching, and until next time, goodbye.